Hi everyone, I am Untitled. In this video, we will solve one problem in chapter 27. A capacitor is first charged until it stores 8.9 joule energy. It is then connected to the circuit given in the figure. The switch is then closed. Within 7.4 milliseconds, the resistor is seen to dissipate 2.8 joule energy. Calculate the capacitance of the capacitor. First, we find the final energy on the capacitor by the formula initial energy minus the energy dissipated by the resistor, 2.8 joules. Initial energy is 8.9 joules. Therefore, final energy on the capacitor is 6.1 joules. Energy stored on the capacitor is calculated as 1 over 2 times C times V squared, where V is the voltage of the capacitor. Another formula is Q squared over 2 times C, where Q is the charge stored in the capacitor. For convenience, we use the formula Q squared over 2C. Remember that the discharging formula is Q final equals Q initial times e to negative t over tau, where tau is time constant, which is calculated by the formula R times C. Anyway, the ratio of the initial energy to the final energy is Q initial squared over 2 times the capacitance of the capacitor over Q final squared over 2C. 2C's cancel each other. Now, we obtain Q initial squared over Q final squared. Since both sides are positive, we can take the square of both sides. So, we obtain square root of U initial over U final equals Q initial over Q final. Q final has the formula Q initial times e to negative t over tau. So the right hand side becomes e to t over tau. Natural logarithm of both sides is ln of square root of ui over uf equals t over tau. Tau is R times C. From this, we obtain an expression for C as t over R times ln square root of ui over uf. Now, we can substitute the numerical figures into this formula. As a result, we obtain approximately 1.63 times 10 to the negative 6 farad, or approximately 1.63 microfarad. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.